We have seen how to compute the inverse matrix. Now let us check what is it good for. The main application for inverse is when we solve a system of linear algebraic equations, and when the system is a square system and when the determinant of the matrix is non-zero. Then the inverse exists and we can find the solution as A inverse B. In the previous section, we considered the example of the matrix to be 2, 3, 1, 1. And we computed, using two different algorithms, the inverse to be -1, 3, 1, -2. So consider such a system of equations with this particular right-hand side. Say B is 7, 4. Then the solution can be written as the product A inverse times the vector right-hand side, the right-hand side vector. And when we use this result from the previous section, the inverse matrix -1, 3, 1, -2, and we just multiply by the right-hand side vector 7, 4, and here is the result, the solution. So this is the solution to the system. And we can check this solution if we substitute x to the original equation. So on the left, we have the matrix A times the vector x, which we hope to be 5 minus 1. And when we perform this multiplication, we get indeed the vector 7, 4, which is on the right. So it looks good. This is indeed the correct solution. If the system is a square system, and the determinant of the matrix is different from 0, then the system has one unique solution, which can be found this way. This is convenient because the algorithm how to compute the inverse matrix is a part of every numerical software. And this is also especially useful when we want to solve many copies of this system with the same matrix A and different right-hand sides. Then preparing the inverse can be done only once, and then if you receive new and new versions of B, you just perform this multiplication with A inverse prepared already, and only new right-hand sides will give you new results for various cases. On the other hand, if you have a very large system and you want to solve just one example, one copy of this problem, then using inverse is not the best, the most efficient way. Gauss elimination is slightly faster, but the difference is important only for many thousand rows and many thousand columns. So this was the illustration of how to use the inverse matrix, and in the next section we will discuss 3 by 3 matrices.